Hey everyone, thank you for the nice introduction. I'm so happy, I'm so grateful to be invited here to this conference in Singapore to speak here. My topic for today is do-it-yourself smart home, and I want to explain you how you can build your own HomeKit accessories. My name is Marius Rackwitz, as you've heard. So first question, why would you do that? What is the motivation behind that? Well, because it's the promised future, because it's the new thing. Control all your lights and appliances at home via Siri, just with your voice, even when you're not at home. So in theory, I should be able to control my smart home appliance just from here via the HomeKit app or Siri with my voice. So why would we want to do that ourselves? Well, available commercial accessories are for the most part not necessarily thought through. Like there are things on the market we didn't even know we would ever need. So in resume, commercial accessories from my experience are either expensive or short-living, immature, and insecure. And that might even extend to those expensive accessories. Here we have one brand of smart lights which managed to set up the update process in such a way that you wouldn't be able anymore to turn your lights on while the lights are updating. But software updates are important, and some manage to have automated software updates. Who would have known that they could lock you out of your own home? So do we need these software updates at all? Well, with this week, it seems like it would be better. There's a new Wi-Fi vulnerability called crack attacks, and it seems to affect almost all devices which support Wi-Fi in one way or another. It affects Linux, Apple, Windows devices, and routers, and even smart home devices out there. So all these points were for me personally a motivation to try to do it myself and rely on what Apple promised us in WWDC with HomeKit, one solution to rule them all, using the local network and access only over an end-to-end encrypted connection via Apple's gateway servers. It's via Apple, so it should be around for a while. I'm not making myself dependent on some cloud, some other people's computers, which might be turned off at some point. So how do we make that happen? Well, our devices have to talk with the HomeKit accessory protocol. What is that? Well, it used to be a closed program, which was only available to commercial MFI program developers and required multiple certifications, the integration of an Apple authentication coprocessor on the hardware side, and was, in addition to that, documented on over 250 pages. Well, with this year, things changed a little, fortunately. There is now a public track for non-commercial use, where it is publicly documented when you click through and accept a few license agreements. And it does not require special chips anymore for that program, but still, that documentation is damn long. Nobody has time for that for a side project. Or good that there are some open source implementations out there. There is a community around HomeBridge, which is based in JavaScript. There's a project called Home Control and Go, and there is something in Swift, which just goes by the name HAP, as the protocol is called. But so much about the software side of things. Where will it run? We will need hardware. Does that mean I need a soldering iron? Not necessarily. It might help so to save on the cost side. But these days, in the age of Raspberrypis, Arduinos, and more, hardware does not have to be hard anymore. There are plug-and-play solutions which allow you rapid prototyping on the hardware side and get you started easily, and you can iterate from there on incrementally using here with the example of the so-called Grove widgets and hardware accessories, sensors and appliances like motors, relays, LCD displays. We see some here in the background of the slide. And there's software out there, and you can just all plug it together and get easily started with it. And based on that, I want to show you a recipe for something I have done myself at home, a smart RGB LED light. So this recipe requires as ingredients a Raspberry Pi, Wi-Fi enabled, so you might require some Wi-Fi dongle in addition to that, which is available at a very small cost. An Arduino, for example, this Grove P I used myself, which has a corresponding widget, an LED strip driver, and for sure some light to bring light in our home, an LED strip. So from the hardware setup, it's all quite easy, no soldering required. To connect the Arduino via its GPIO pins to the Raspberry Pi, connect the LED strip driver to the Arduino, and connect the LED strip to the driver, because names match, so they should also match. And in the end, we need to connect it all with power. From the software side, we need a fitting operating system for the Raspberry Pi. That can be, for example, Raspbian, which is a Debian-based Linux distribution. But beside that, we also need to bring some own software to make that happen. We will bring in some software written in Swift on the Raspberry Pi to pitch our hardware to HomeKit, and our own firmware in C to take comments from this software on the Arduino and pass them on to our hardware. So let's take a look how that could look like. Here is the setup phase of the firmware. We already have some hardware abstraction layer here for the LED strip. We set it up with what pins we are using, also what pin we are using for the I2C connection we are talking over to our Raspberry Pi. Then we're doing some setup routine for hardware, initializing the color to all black, so starting off with having it dark, and starting the wire I2C slave here. The loop is just standard Raspberry Pi C boilerplate. Don't worry about that. And then we have the receive data routine. And that is just waiting until there's something on the wire, reading whatever comment is on there, and then reading the bytes in the defined order, which are our color components, red, green, blue. And then in addition to that, we want smooth transitions between different colors. So we take a delay, and that is coming in two separate components because we want to allow bigger numbers than what we could just transfer with a single byte, and combine them together into a long and pass them on into the method called fade to color of our hardware abstraction layer. On the software side of things, we can use a library which provides already abstraction around the I2C communication for Raspberry Pi, and knows a lot about how the hardware looks like and work. So we don't even need to worry in concrete what different Raspberry Pis can do and how they look like. We can just tell what device in concrete we are working with. And then we will duplicate the what we have done on the firmware side of things on the software side of the whole thing as well, and have an abstraction layer so that we can have an easy communication, and in the end use the HAP library to bridge the hardware to HomeKit. So here is how the hardware abstraction layer can look like. Again, we are working with the I2C interface, and the only thing we are offering out as public method to interact with is fade2, which is the method which allows us to set the color, and that is just transforming the higher level data types. Here we assume a struct-like data type just to describe a color, which we split up in its components, the bigger data type for the delay, and put this all on the wire with our comment we have negotiated between the two software sites we are writing. And that is the hardware abstraction layer that we can use from our HomeKit bridging server. There we need to describe to HomeKit what we have here and what we are offering to HomeKit as an accessory to interact with. Therefore, we're using a light bulb because that's close to our LED strip we have, putting that into a bridge to put it into the correct hierarchy HomeKit is expecting. The bridge is the actual device you connect. Underneath that, there could be a bunch of more sensors and appliances you want to work with. If you have ever set up something with HomeKit yourself, you might have seen that with other things. Yeah, and then just start the server. In addition to that, we need to set up events when something has changed to the HomeKit appliance we are working with. This is just all the same for all the different characteristics. That includes hue, saturation, brightness, and whether it's on or not. So it's in differentiation from what we have used before, not RGB, but HSV, a different way to describe colors. And so this is basically the only step we have to do here. We need to remap our colors from the different scheme to describe them as a struct again, and just pass that on to our hardware abstraction layer. And that's it, basically. But there are some caveats. So Swift on Linux so far is a proper subset of Swift. It's not the exact same and will never be as we're used to as iOS developers. Swift on ARM, in addition to that, is also not quite the same. And Swift on ARM requires so far a custom-built toolchain, so you need to do some extra effort. But other than that, we are set up and ready for profit. Well, maybe not profit, but more a bunch of fun and some learning experience. I thank you for your attention.